everyone, I'm Balaj. Today I'm going to present Splunk Nexus AI. So Splunk Nexus AI is um, built with self-healing infrastructure. So the problem what we are going to see is what current infrastructure holds. Like it's mostly broken. Like most of the industry uses a microservice and they generating billions, millions and billions of events daily. And my dear average is 45 minutes with the traditional monitoring and average alert fatigue. Stream drowning with the noise and real signals are missing and the approach is what team is taking is a reactive firefighting where the user is already impacted and the security threats evolve more faster than human response and every minutes of downtime cost enterprise $5,600 on average. So what the solution what we are providing is it's a self-healing enterprise. It has a 5 stages. One is a predict, detect, and diagnose and fix and report. So it is a autonomous digital twin of an infrastructure with seven specialized AI that work together. So what is happening? So what is an architecture? So the architecture is a multi-agent architecture. One is a supervisor route. It's a route specialized and root cause analysis. It's a Splunk MCP log correlation and crisis handler. So that's assess the blaster radius assessment and the third one and another one is a remediation out of fix and validation and it's provide the executive reports. So it is powered by Splunk, so that's our observability data via MCP and log chain. So that's a stateful multi-agent orchestration and Neo4j. So that's for our knowledge graph for the dependencies and quadrant. So that's a vector search for the similar incident and we are using Gemini for the fastest accurate LLM reasoning. So the output what we are going to see is it's a live monitoring tool. So here we have a it is a mission control, so where it is giving all the details. There are four agents has been actually active and what is happening incident list has been provided here and the AI insights, what is the AI is doing, how it is predicting the confidence scores, percentage, everything will be displayed in the mission control itself and AI collaboration feed. So what is AI have been doing? So this is the agent. So there are 8 agents. What is the status of an agent? We are going to see. So the crisis command center is the one which handles the P1 and other critical infrastructure and what is doing, how it is analyzing the things. So this is fully autonomous. So it is detecting and analyzing and assess the uh, blaster radius and it's planned for the generated run book and it execute and validate and gives a report. So this is the timeline. So the event has been occurred and then the supervisor get the incident automatically and then it routes the it supervises the routes to root cause analysis and the root cause analysis provide what is the SPL query and it is analyzing the things and then root cause is giving the connection pull exhaust and then the supervisor escalating this to a command center, crisis command center. So crisis command center identify the blast radius, like there are 3 services and 240 2400 users has been affected and then the remediation kick place, then the final is updated in the crisis manager, it is resolved and then it executes the report. So digital twin, so this is an infrastructure for the for the enterprise. So it is giving the overall like how your application and what are the resources has been affected. So this is a payment service. It has been the health is critical, and then if you see this the CPU and memory is triggering. So this is like you will get an overview of an infrastructure in a digital twin, and then what is a service heat map like health of your service. Which are working fine, which is not working fine. Like clearly the payment is the one is affected. So agent swarm is the agent status. There are agents, how they are, what they are doing, what is the action they are taking, what is the status they are in, and so those details. And below is the decision trace. So what is the a agent is doing, and these are all will be logged so that you can be used. And then investigation. So in the investigation, what are the what are the high alerts has been prioritized, and what is is doing the attack chain, what is happening, so in the attack chain, what are the things has been, so what is the count of the evidence, so those things will be identified, and indicating the compromise, like what are the IPI machines has been compromised, so those things will be given. And then the final is executive report. So the it's a dashboard where you are given the overview of infrastructure, what is the system reliability, the mean time to the resolution is 23.4, and then the cost of add-ons is like the downtime what we have saved for this week is 148K. So what is automation rate, and what is the meteor trending in a minutes, and like in the week span, like how it's responded, and then incident the trends for the last 7 days, incident by the severities, like how many incidents has been happened, and what is the category, and what is the number of count for the incident, and it's an executive summary what is given. So this is a generate, so you can export it as an PDF as well. So this is uses a backend API. So these are backend. So we have open API standards, like created the APIs for the application. So the final thing is like the dashboard, the report dashboard. So here, what is the Nexus AI is improving. So my tar, so it's before 45 minutes, it will take with the traditional monitoring, and now it's cut down to 23 minutes. So that is a 62% improvement. And then the MTTD is 15 minutes, like that is with the Nexus, it's a 4.2 minutes. So that solving the incident is very quicker. So that is a 72% of improvement. And then automation is now we are achieved 87.5, but we can go higher. Cost avoidance, like we are avoiding with the with the Nexus AI, we can avoid the downtime cost for that infrastructure is one lakh 47,500 USDs, and security response is less than a minute. So it's a great improvement, and thank you, everyone.